Dear friends, welcome to Bond with Electrochemistry YouTube channel. In this video, I will explain the previous year questions from HCU PG Entrance Examination from named reactions in organic chemistry from the year 2010 to 2020. The major product formed in the Chichi-Babin reaction is, in Chichi-Babin reaction, this is a reaction of pyridine with the amide, potassium amide as a sodium amide dissolved in ammonia. There is a nucleophilic substitution in pyridine at second position. Here there is a nucleophilic substitution at second position and there is a formation of 2-aminopyridine. So this is the correct option. Identify the name of the following reaction. Here identify the name of the following reaction. Okay, this is a reaction in presence of light. It's a photochemical reaction. There is a alpha cleavage. Here there is alpha cleavage. Here also there is alpha cleavage, and there is a formation of free radical. And these two free radicals will be combined, and there is a formation of CC bond. This reaction is a Norris type 1 type of reaction. In Norris type 2 reaction, there is a abstraction of intramolecular abstraction of gamma hydrogen takes place in carbonate compounds. Paterno-Bucci reaction, this one is a reaction between carbonate compounds. It's a photochemical reaction between carbonate compounds and alkenes, and there is a formation of oxygen. Barton reaction, this one is exhibited by alkyl nitrides. There is a intramolecular delta hydrogen abstraction, and there is a formation of delta nitroso alcohols. So the correct option will be, this reaction will be Norris type 1 reaction. The name reaction which is used for the conversion of salicylaldehyde to catechol is, here this is salicylaldehyde OH, and this one is C double bond OH. When you treat with hydrogen peroxide in presence of base sodium hydroxide, there is a hydroxylation in place of C double bond OH, and this one will be converted into HCO O minus. This is the catechol. This reaction is called as Jakin reaction, the conversion of orthohydroxy aldehydes or ketones or parahydroxy aldehydes or ketones into orthohydroxyphenols or parahydroxyphenols is called as Jakin reaction. In Wills-Mayer-Hack reaction, we can prepare aromatic aldehydes or ketones. Shapiro reaction, this one is used for the preparation of alkenes from carbonyl compounds. Riemann-Tiemann reaction, it's a formylation reaction in phenols. So this is a suitable method. Jakin reaction is a suitable method for the conversion of salicylaldehyde into catechol. The reaction which gives beta hydroxycarbonyl compounds as a product is, in Cannizzaro reaction, we will get alcohol and carboxylic acid. It's a disproportionation reaction. There is a self-oxidation introduction. Here we will get alcohols and carboxylic acids, and the glycine condensation we will get alpha beta unsaturated esters. Benzoyl condensation we will get alpha hydroxy ketones. In aldol reaction, there is a formation of beta hydroxy carbonyl compounds. Further condensation you will get alpha beta unsaturated carbonyl compounds. D is the correct option. Intermediate involved in the Riemann-Tiemann reaction is, Riemann-Tiemann reaction is a formylation reaction of phenols. In Riemann-Tiemann reaction, we use chloroform and sodium hydroxide and potassium hydroxide. When you treat chloroform, the sodium hydroxide, excess amount of sodium hydroxide, there is a alpha elimination or 1,1 elimination takes place, and there is elimination of both hydrogen and chlorine, and there is a formation of dichlorocarbene. This is the intermediate which is generated in the Riemann-Tiemann reaction. So in Riemann-Tiemann reaction, we have carbene as an intermediate. Which one of the following reactions involves both oxidation and reduction processes? Kenizero reaction, if you take Kenizero, two molecules of aldehydes which are not having alpha hydrogens, when you treat with the OH minus, in presence of OH minus, so there is a self-oxidation and self-reduction. The aldehyde will be oxidized into carboxylate and reduced into alcohol. It's a disproportionation reaction. This reaction is called as Kenizero reaction. In Kenizero reaction, we have both oxidation and reduction. The major product obtained in the following transformation is, this is diene. Diene is given, and this is diene of 5. Here there is a 4+2 cycloation reaction takes place in presence of heat. It's a Diels order reaction. In Diels order reaction, endo product is measured. In endo product, this ring should be below to the display. When this ring is below to the plane, the hydrogen should be above the plane. So this is not correct option. Both are below to the plane. This is not correct. One is below, one is above. This is also not correct. Here also both are below to the plane. When this diene approaches below to the plane of diene, this should be below to the plane and the hydrogen should be above the plane. So this is the correct option. The reaction that involves formation of both CC and CO bonds is Diels order reaction. It's a 4+2 cyclohexane reaction. There is a CC bond formation. It's a CC bond formation reaction. Aldol reaction, it is also CC bond formation reaction. Beckmann's rearrangement, oxides will be converted into amines. Dodge's glycidic ester conjugation. In Dodge's glycidic ester conjugation reaction, it's a reaction between carbonyl compound and alpha halo ester. This is the alpha halo ester I am taking. In this reaction, there is a bond formation between this carbonyl carbon and alpha carbon to the ester, and also there is a CO bond formation between this oxygen and this carbon. Finally, you will get this is the oxygen. Here there is a CC bond formation. Here also CO bond formation, and finally we will get the C double bond OH. This one is alpha beta epoxy ester. This alpha beta epoxy ester is called as glycidic ester. In Dodge's reaction, we will get glycidic ester, and in this reaction, there is a formation of CC and CO bonds. The key reagent in Woodward cis dihydroxylation is Woodward cis dihydroxylation reaction. This is the reaction when you treat with the acetate, silver acetate, iodine, and in presence of water, there is a formation of cis diols. There is a syn addition takes place, and there is a formation of syn diols. But if you change the reagent, if you change C6H5 COOAC and I2 in absence of water, in presence of benzene or in absence of water, there is a formation of trans diols. In this case, we will get trans diols. There is an anti diols we will get. So this reaction is called as a Prevost. This is a reagent which is used in Prevost, and this reagent is used in Woodward reaction. The HVZ reaction is it's a alpha halogenation of carboxylic acid. So this is the reaction RCH2 COOH. For this reaction, the carboxylic acid should contain alpha hydrogen. In presence of PbR3 or P plus Br2, there is a alpha halogenation RCH Br and COOH. This reaction is named as HVZ reaction. Identify the reaction involving olefination of ketones from the following. Friedel-Crafts, it's an acylation reaction or alkylation reaction. Wittig reaction, these carbonyl compounds, okay, when you treat with phosphorus ylides, when you treat carbon compounds with the phosphorus ylides, there is a formation of alkenes. Here there is olefinition of ketones takes place. Cannizzaro reaction, here there is a self-oxidation and reduction of aldehydes into carboxylates and alcohols, and a Smith reaction is a rearrangement reaction. In this reaction, azides will be converted into amides. Conversion of phthalaldehyde into 2-hydroxy-methyl benzoic acid is an example of phthalaldehyde. This is phthalaldehyde. This one is the C double bond OH, and this one also C double bond OH. Okay, when you treat with OH minus concentrated NaOH, there is a self oxidation and reduction intramolecular. This one will be converted into COO minus, and this one will be converted into CH2OH. And here there is a formation of 2-hydroxymethyl benzoic acid. It's an intramolecular Cannizzaro reaction. It's a Cannizzaro reaction. The reaction takes place within a molecule, so it's an intramolecular Cannizzaro reaction. The enolate responsible for the formation of a stable intramolecular aldol product from the following diketone will be. In aldol reaction, there is a formation of enolate, stable enolate. The stable enolate, the enolate which contains a double bond, more substituted double bond, that enolate will be stable. Here we have this enolate. This is the enolate. Here this is the enolate we are getting. Here this is the enolate we are getting. Here this is the double bond position. Among these 4 double bonds, this one is more substituted. More substituted double bonds containing enolates are more stable. So we will get this enolate in this aldol reaction. The most appropriate reaction that produces compounds containing alpha hydroxy ketone moiety is in benzoin conjugation. When you treat aromatic aldehyde, benzaldehyde with KCN, H2O, and ethyl alcohol, there is a formation of pH C double bond O, CHOH, and here there is a pH. Okay, there is a formation of benzoin. The conversion of benzaldehyde into benzoin in presence of potassium cyanide is called as benzoin conjugation. In benzoin conjugation, we have alpha hydroxy ketones. Identify the most appropriate reaction for the carbon homologation. Ordered isotope reaction, it's an example for carbon homologation. There is an increase in chain length. Let's take RCOOH. It's a carboxylic acid. We can increase one carbon in RCOOH by using SOCl2 and CH2N2. When you treat with CH2N2, AC2O, and water, finally you will get RCH2COOH. There is a homologation of carboxylic acid takes place. This reaction is named as Ornett isotope reaction. Identify the most appropriate reaction involving hydrozoic acid as the reagent. The Gaseous reaction, this is the reaction RCOCl and sodium azide. When you treat, there is a formation of RCON3. When you heat it, there is a conversion of this azide into isocyanate, R and double bond C double bond O. So in this reaction, Gaseous reaction, we use acyl acids. In Smith reaction, we use RCOOH, carboxylic acid, and hydrozoic acid, HN3. So when you treat with, finally, these will be converted into isocyanates. So in Smith reaction, we use HN3 as a reagent. In Hoffman's degradation, we use amides, and amides will be treated with NaOH plus Br2 or NaOBr. NaOBr is a reagent. Swarovski rearrangement, this one is alpha halo ketones will be converted into carboxylic acids in presence of base. Identify the most appropriate reaction which employs formaldehyde as the key substrate. In Grignard reaction, there is no involving of formaldehyde. Michael addition reaction, in Michael addition reaction also there is no involving of formaldehyde. Friedel-Crafts acylation or alkylation, there is no involvement. In Prince reaction, this is the reaction between ketone, C double bond O, and alkene in presence of acid. Here we can take formaldehyde. In presence of acid, there is a protonation. So there is a protonation of formaldehyde takes place. Here we will get positive charge, and this alkene, the pi electrons will attack, and there is a electrophilic addition reaction takes place. This electrophilic addition reaction between carbonyl compound and alkene in presence of acid is named as Prince reaction. In Prince reaction, we use formaldehyde. The process of conversion of a mixture of carbon monoxide and hydrogen into liquid hydrocarbons is known as. Here, Ziegler synthesis, this one converts alkenes, ethylene into fatty alcohols. Fatty alcohols. We get straight chain, long chain alcohols. This is the organopalladium catalyst. Organopalladium catalyst. In presence of organopalladium catalyst, alkenes will be converted into fatty alcohols. This is Ziegler synthesis. So Frankland synthesis, it's a modification of Wood's reaction. We can prepare alkenes from Frankland synthesis from alkyl halides. Corey-House synthesis, this is also used for the synthesis of alkanes. In this reaction, we use alkyl halides and reagent, Gilman reagent R2CuLi, and there is a formation of alkane. In Fischer-Tropsch synthesis, we use carbon monoxide and the hydrogen. These reaction between Cu and H2 will give higher hydrocarbons, higher straight chain hydrocarbons. So this process is called as Fischer-Tropsch synthesis. Identify the most appropriate reaction from the following which converts benzaldehyde to benzyl alcohol and benzoic acid. Okay, this is a Cannizzaro reaction. In Cannizzaro reaction, here there is no alpha hydrogen in presence of OH minus. So this one is converted into, there is a self-oxidation and reduction. So this one converted into COOH and CH2OH. So this is the Cannizzaro reaction. Raymond-Heyman reaction, it's a formylation reaction in phenols. Perkin reaction, there is a formation of alpha beta unsaturated aromatic carboxylic acids, and Catius reaction, we will get amines. Finally, we will get in Catius reaction, there is a conversion of azides into amines. Hydrozoic acid is extensively used in a Smith rearrangement. In Smith rearrangement, we use hydrozoic acid RCOOH plus HN3. Finally, there is a formation of isocyanate. When you treat with water, you will get Na. In Beckmann's rearrangement, it's a rearrangement of oxides. Here there is no involving of hydrozoic acid. Catius acyl azides we use, RCON3 we use. Hoffman rearrangement we use NaOH and Br2 reaction of amides with NaOH and Br2. Robinson annulation. Robinson annulation, it's a ring formation reaction. First there is the Michael addition. After that there is a aldol conjugation. Okay, this reaction involves two named reactions. First one is Michael addition. Next one is aldol conjugation. Among the following reactions, the one which will not result CC bond formation is Riemann-Tiemann reaction. It's a formylation reaction. So here there is a CC bond formation. This one will be converted into OH and C double bond OH. Here there is a formation of CC bond. Friedel-Crafts alkylation, acylation also there is a CC bond formation. Which reaction? Here also there is a formation of CC bond. In Kenzero reaction, the aldehyde is oxidized and reduced. Here there is no formation of any bond. There is no formation of CC bond in Kenzero reaction. The product obtained in the following transformation is. Okay, this one also one type of Kenzero reaction. Here this group, keto group, and this group is the aldehyde group. The aldehyde group will be oxidized and the keto group will be reduced. So here it's an intramolecular Kenzero reaction. So this one converted into OH and this one will be converted into COOH. So this is the correct option. The major product obtained in the following reaction is. Okay, in this case, this one has lone pair of electrons. So these electrons moves in this direction and these electrons moves in this direction. So this is the moving of electrons in diene. OMB. It's a Diels order reaction between diene and dienophile. These electrons moves like this. These electrons moves like this. And here there is a possibility of this one and COOMB. And also there is a possibility of another thing when there is a movement of electrons like this. Another thing is C double bond OMB. And which one is favorable? Here when there is a movement of electrons like this and when movement of electrons like this, these electrons moves like this. And these electrons moving towards electron withdrawing group, that is COOMB. So this one is favorable. Suppose if you take this one, when these electrons moving in this direction, these electrons moving away from the electron withdrawing group, so this one is not favorable. So in this case, there is a bond formation between this carbon and this carbon, and here there is a formation of double bond. So you will get this compound. Here you have OMB, and here you have CO2, and so D is the correct option. The major product obtained in the following reaction is. Here aldehyde is given and first it is treated with hydrogen, so there is a formation of hydrogen, and when you treat with base and when you heat it, the CHO RC double bond O H will be converted into RCH3. RC double bond O will be converted into CH2. Okay, this reaction is Wolff-Kishner reduction reaction. So the CH4 will be converted into CH3. What is the correct option? This CH4 will be converted into this CH3. So A is the correct option. The most probable product obtained in the following transformation is. Here iodine and silver acetate is given, acetic acid, and wet condition water is given. It's a Woodward hydroxylation reaction. It's a syn hydroxylation reaction, so you will get syn. But here we have to consider steric factors. Me is above the plane, so there is a approaching of I2 below the plane. So you will get below the plane, the two OH groups will be below the plane. So you will get this compound. Identify the most appropriate reaction which involves one CC bond and one CO bond formation. Already this question was asked. It's a Dodgen's conjugation reaction. Phenyl isocyanide is prepared by. It's a carbylamine test. In carbylamine test, primary amines, when you treat primary amines with chloroform and KOH, with KOH, there is a formation of isocyanide and there is a formation of HCl, KCl, and also there is a release of hydrogen gas. Here there is a formation of isocyanide. Phenyl isocyanide can be prepared by carbylamine reaction. The intermediate involved in the Gaseous rearrangement is. In Gaseous rearrangement, this is the reagent. RCOCl is converted into. When you treat acid, there is a conversion of RCON3. When you heat it, This one will be converted into R, N double bond, C double bond O. In between, you will get nitrene intermediate, RC double bond O. Yeah, this is the intermediate you will get in Curtius rearrangement. Loss in Curtius Smith often in all these reactions, the intermediate is nitrene intermediate. The major product obtained in the following transformation is it's also intramolecular Cannizzaro reaction. Here there is a reduction, here there is a oxidation. So you will get OH here, and here you will get COOH. And after treating with methyl alcohol and heat it, there is esterification reaction. In place of OH, you will get OCH3. So this is the correct option. Thank you. Thank you very much.